bersama aman sentosa selama-lamanya.
All right, ladies and gentlemen, that is a cultural dance that depicts the multiracial Malaysia and also the indigenous dance from our state of Sabah and Sarawak as well. So you guys, the truth is, if you can see, there are maximum of 6 to 7 dancers on stage at one time, right? And you can see there's a lot of free space. Yeah? So if you are here, we will pull you in to fill up those space and dance. Please take note. We will do that in the next CoSMEd 2023, live here, face to face. Yeah? Okay, guys. Now, that is a cultural show. So if you have a science conference, science education conference, it can't be just a cultural show. It has to be a science show. Then you can call a science conference. Ladies and gentlemen, a science show by local company called Penang Tech Dome. Enjoy the show, ladies and gentlemen.
Meet Fatin, a seemingly ordinary high school student, but unknown to even her friends. She has a dark secret, or should I say a bright secret. Fatin is a highlighter fanatic. No textbook is safe, and her study notes look like works of art. This is proven. As a child, he was deathly scared of the dark. 10 years later, he had a glow stick accident that turned him into Glow Stick Man, and now the dark fears him.
Hi! Light has a wide spectrum, but not all of the spectrum is visible to eyes.
Light waves can be absorbed by certain objects and emitted as a visible light. Let's use this tonic water for the first demonstration.
Tonic water looks white under normal light.
Now, let's look how it looks under UV light. Jarvis, light off.
Tonic water has quinine. Quinine absorbs ultraviolet light and re-emit it as visible light, which means it appears to glow in the dark.
Light waves can be absorbed by fluorescent liquid and emitted as visible light immediately. Let's do this. Safety gears on, Fatih.
Alexa, lights off. The highlighter liquid is fluorescence. It absorbs light energy and emits the light immediately. You will be able to see it glow under UV light or black light. So Puvan, why don't we make a lava lamp that glows in the dark?
That sounds epic. I'll never say no for that. Let's do it.
Lava lamp is all about density. Oil is less dense water, so it floats on water. When we added the fizzing tablet, it dissolves in water and produces carbon dioxide gas bubble. Air is less dense water and oil, so it brings together the glowing liquid to the top layer. When the bubble pops, the water-based glowing liquids will again sink to the bottom. The cycle then continues.
For the last demonstration today, I have some spooky glowing signs for the viewers. Fatin, can you bring me the secret ingredients?
What secret ingredients?
Oh, come on Fatin, don't pull my leg. The viewers are watching.
Don't worry, Puvan, I'm just kidding. We have it here. Dry ice is the solid form of carbon dioxide, and it will sublimate into vapor. When we drop it in water, it forms a cloud and starts bubbling. the show.
Have a productive conference and stay safe, everyone.
Bye-bye.
Bye.
All right, ladies and gentlemen, that is the science show. Now, if you can see, it looks like magic though. Can you see me? I can also do a science show. This is called magic as well. Can you see me right now? See me? See my face? I'm disappeared and you can still hear me, right? Correct? You can hear me, right? Appear. Disappear. Appear. So this is called magic. Now, this magic, you have seen it before. Many of you seen it, especially teachers who attend conference. In your classroom online, you always go and check on your students, but they never appear their face. Always, students, where are you? Do you understand? Still students? Yes, teacher. You can only listen to their voice, but never their face. This is also magic. Also conference, attending a conference, when you go into breakout rooms, sessions and so on, you can only see. All right, ladies and gentlemen, do you understand the conference workshop? Oh, yes, yes, yes. You can only hear the voice, but they are there. They are there. They're always there. Only when you call up their name, they will appear. This is also called magic, ladies and gentlemen. Yeah? Okay, guys. Let us start. The biggest session of them all, keynote address number 1. Prof. Ryohei. Sensei, are you there? Prof? Prof? Now, this session will be co-moderated by Dr. Wan Norazmin binti Muhammad Sabri, the Deputy Director for Training and Research of Rexam, and moderated by Professor Dr. Amelia Buan from the Philippines. Ladies and gentlemen, I'm not going to do anything. I'm going to sit back, enjoy the keynote address, entitled Youth as Agent of Change in Society Through Their Mathematics and Science Learning in the New Normal. With that note, ladies and gentlemen, I hand over the sessions to Dr. Wan Norazmin. Over to you, Dr. Min.
Okay, thank you, Mr. Nizam. Bismillahirrahmanirrahim, and a very good morning, ladies and gentlemen. Welcome to our first keynote address. I'm Dr. Wan Nur Azmin binti Muhammad Sabri, co-moderator for this session. Participants are encouraged to explore the material, ask questions, and share ideas with us. I hope all of us will enjoy this session and benefit from the outcome. Thank you from Rexam. A friendly reminder before we proceed, we encourage the usage of desktop, laptop, or tablet instead of handphone. For each participant, please use only one gadget to avoid echo or microphone feedback. Also, please mute your microphone throughout the session. Without further ado, let me introduce the moderator for this session is Dr. Amelia T. Buan from Mindanao State University Iligan Institute of Technology, Philippines. Dr. Amelia T. Buan is a mathematics education professor and a research and evaluation expert at Mindanao State University Iligan Institute of Technology, Philippines. In 2015, she was chosen as one of the 40 Intel education visionaries for her insight, passion, and proven experience as an agent of change in education. She is involved in nationwide STEM initiative in the Philippines, being one of the trainers of the Department of Science and Technology, Science Education Institute's project STAR, training teachers on the effective use of various mathematics teaching approaches. For example, teaching mathematics through problem solving and lesson study as a tool for teacher professional development. Dr. Amelia T. Bond, the screen is yours. Thank you.
Good day, everyone. Our first plenary speaker is an education advisor in science and mathematics at Keime Gakuen Junior and Senior High School, Japan. Professor Miyadira first received his PhD in mathematics from Osaka City University in 1990 and his second PhD in mathematics education at Kobe University in 2006. Both of his studies focus on probability theory. Professor Miyadira was a Kwansei Gakuen High School teacher and a former lecturer in the science department of Kwansei University. For 26 years, he has been engaged in high school mathematics research. His notable works of Professor Miyadira, together with his students, include 16 referred papers on pure mathematics and 20 papers on mathematics education. With his effort on innovation and research in mathematics education, he was awarded as an Excellent Teacher Award in the year 2012 by the Japan Ministry of Education. In the same year, he got the Wolfram Innovator Award from Wolfram Research. In 2015, Professor Miyadira became one of the recipients of the Masatoshi Koshiba Award for Education, a prize made in commemoration of a Nobel laureate, Masatoshi Koshiba. Recently, Professor Miyadira was awarded by Hyogo Prefecture Award of Education. Today, ladies and gentlemen, to share his take on youth as an agent of change in society through their mathematics and science learning in this new normal, ladies and gentlemen, please help me welcome Professor Dr. Ryohei Miyadira.
I am Ryohei Miyadira. I'm very happy to be able to talk at this conference. In this talk, I would like to present a method of mathematical education that cultivates creativity. I have taught students how to do mathematics research for more than 26 years. My students and I have discovered many formulas and theorems, which we have published in mathematics journals in 8 countries. These are pictures of journals in which we published our research. Many of my former students are doing very well in academia, and many of them are doing very fine work in industry. I can say that their performance go well beyond the expectation of their former teachers and the people around them. One former student has set up an IT company that is a forerunner in Japanese IT security. Another former student has set up a startup company that applies AI in medicine, and another set up a company that checks the quality of man-machine interface in computer applications. 2 of them were 22 years old and the other is 30 years old. And I have another former student who has already published papers as an undergraduate. These are home pages of their companies. I would like to attribute their success to the fact that they learned how to be creative while they were high school students. I am confident that I have a good method that cultivates creativity. which is the subject of my talk today. The importance of cultivating creativity is well recognized by most educators. Although scholars have divided opinions regarding when students should learn to be creative. The modern world has a lot of difficult problems to solve. Some of which are environmental, some are medical, some are social, etc. The existence of both mankind and all other living creatures is at stake. Now is the time to gather all the abilities of mankind together to attend to these problems. We will need very creative people. In traditional education, students do not learn to do new things at junior high or high school. Even in universities, students spend most of the time getting knowledge. Although there are still many educators who think that it is not a good idea for students to try to create new things before they have acquired sufficient knowledge. The trends in education are going towards active learning, in which students are expected to create new things at quite a young age. I think that it is very important for students to learn to be creative when they are in both junior high and high school. Then they can have enough knowledge to create something new. This year, I started teaching at 2 schools that are new to me. Throughout my long career as a teacher, I have taught at private schools, but I'm now teaching at both a private school and a public school. And this time, my research group includes several junior high school students. With this new school and new students, I'm starting to find that my methods are quite effective. I mean, very effective in most schools. As my students discover new things, I started realizing that our research has been accomplished by making variations of existing programs by revising some of their elements. In 2017 and 2018, my students and I were invited to Wrexham in Penang to conduct a workshop for teachers. After that workshop, we constructed a method that consisted of several small steps by which students are required to make variant to the original problem. I'm going to introduce this method here. What I'd like to emphasize is the use of Mathematica in our activity. Wolfram Mathematica is powerful mathematics software that we can use for free online, although the desktop version is more powerful and useful. With good software, students can get powerful tools with which to investigate the world of mathematics. The method of high school mathematical research proposed herein consists of the following 7 steps. Step 1. Students learn some problems from a teacher. Step 2. Students propose variants to the original program by changing some of its part. Here, students do not choose the topic of their research by themselves. Teachers prepare good programs for them. In the usual mathematics class, students then begin to solve problems. But in my method, instead of solving them, they make new problems using the program prepared by teacher. Step 3. They choose a good program from the proposed variant. So they choose good one from the programs they made. They study the chosen program with the computer. Step 5. They study the result of computer calculations to find some interesting patterns or facts. Step 6. If they can find interesting pattern or facts, the student and teacher prove the existence of patterns or fact mathematically. Sometimes they need to seek help from professional mathematicians. Step 7. If the result is interesting enough, they get a good grade in class, perhaps. And if the result is very good, they can submit the result to the contest. Or if it's really good, maybe to a journal. I'm going to explain these steps more precisely. First, I discuss step 1, 2, 3, and 4. In these steps, students learn some programs from a teacher and students propose some variant, some new program made from the original program. They choose a good program from the variant proposed, which they then study. I use some examples from our previous research. In this example, the original program is as the following. Please make a cup using a rectangular sheet of paper by cutting out 4 squares from the 4 corners of this 2 by 2 square sheet of paper, as shown in figure 1. This is a typical program that most Japanese students learn in 11th grade. I gave each student a sheet of paper and asked them to make a cup with it. Students made various cups, including the following. Students made many kinds of cups, and I advised them to choose this one, this cup. It's a very simple one. Usually, it's best to start with a very simple one. In mathematical research project, some people think it's better not to give any hint when choosing a topic. In fact, when I teach at public school, students choose their research topic by themselves because this is the school's policy. Although I have a lot of experience in high school math research, I find it difficult to get a good result at this school. In my method, I give students some programs with which students make new programs. Some people think that in my method, I'm restricting the freedom of students. My opinion is that most people can easily utilize their creative ability when certain restrictions are placed on their means of expression. For example, in the field of psychotherapy, there's a sandplay therapy, in which clients are supposed to create a kind of play world using a box filled with sand and a variety of miniature toys. The client should use the box and toys provided by the therapist. So it seems that the client does not have true freedom of expression. But this is not the case. Most people find it easy to express their innermost world with this therapy. These were made by clients who came to the therapist to seek assistance. By a given box filled with sand and figures that therapist provided, clients can express themselves. I myself have experienced this sand therapy. At first, I felt frustrated because I love painting and I love to paint what I like. With this box and figures, I thought that I did not have freedom. But when I did sand therapy, I was able to express my innermost feeling. I did this kind of things with my fellow teachers. In Japan, this is another example. There's a very unique style of poem called haiku that consists of 3 sentences, in which the first sentence consists of 5 characters. The second is 7 characters. Another third, and the third is 5 characters. There are several million people who constantly create haiku and show their poems to their others in Japan. Perhaps people in other countries find it astonishing that millions of poets exist in Japan. In this case, the strong restriction on the number of characters helps people create haiku, which are considered the shortest form of poem in Japan. This is a very well-known haiku and its English translation. This is very known haiku and its Malay translation. This is a homepage of haiku contest by a company that sells bottle of tea. This year, about 1.9 million haiku poems were submitted to the contest. In my case, in my method of research, I give students some specific problems, which is a kind of restriction on the student's activity. But this makes it easier for them to think up good programs by changing certain parts of given program. I would like to talk a little bit more about this program of cup. When we start studying this cup, we find out that getting the maximal value of cup requires very complicated calculations. Here, the power of Mathematica was very helpful because of its capabilities in symbolic and numerical calculations. Eventually, the result of research was published in the Mathematics magazine for origami. I will show some calculations. The volume is expressed by this equation, V, and to find the biggest volume, we have to solve this equation with quite a big coefficient. But Mathematica finds it quite easy to solve them. This is another example. 2 players take turns On their turn, they must break the chocolate bar along any one of the horizontal and vertical lines and eat a smaller piece. In this case, eating the bigger piece would be very rude. When the two pieces are the same size, the players can eat either one. I gave this program to students, and students started modifying this game and presenting these chocolate bars. But if you want to study these chocolates, we need many variables like this figure. I advised the students to make a simpler chocolate game. I told them that we need many variables to represent the chocolate. Then students proposed these very simple chocolate. In this case, we need x for the height and y for the width. 1, 2, 0 is for one missing part, two missing part, and no missing condition. It is sometimes important for a teacher to advise their students to simplify the programs. And these chocolate bars turned out to be very good topic for our research, and we presented our result at the International Mathematics Conference. Here, the interference by the teacher in choosing the program was very effective. I often find that students tend to create very difficult programs, and it is teachers' role to simplify them. In this research, we used mathematics software Mathematica a lot. Even if you do not know much about Mathematica, it is easy to use if you have someone who knows the software well to assist you. Even if the program for the research is complicated, you can create a new program with small changes to the original one. This is a program to study chocolate games. And if you change the line in blue, then you can study another chocolate game. Lastly, I would like to talk about the programs that teachers give their students. Since junior high and high school students usually do not know much about mathematics, it is a good idea to choose math puzzles and math games for the programs we give. This is a very well-known math program book, but it contains many programs that can be called puzzles. Some people think that real-world applications are very important for any subject. For them, math puzzles and games seems to be just a hobby that has nothing to do with the real world. I do not agree with this. I find that math puzzles and games constitute a very important field of mathematics. There is also the application of math games to the research of artificial intelligence. However, it may be a good thing to use real-world programs in student research. If you need programs that have something to do with real world, the theory of voting is a good topic. In society, we must often make decisions that have several options. And when there are only two options from which we can choose, we can just follow the majority rule. However, when there are more than two options, there are many different voting systems. This is an example. In a company, there is a committee that selects the next president of the company. There are three candidates, A and A, B, and C. There are 8 members in the committee, and the result of their vote is as the following. If we use only the result of first choice, then C drops out of the competition and we have only A and B. And if we use the result of then if the members of committee votes for A and B by the following table, we know that A will win in the selection. These kind of things often happen in any kind of committee or at school. But we can use another way of selecting the president by giving first, second, and third 3, 2, and 1 points. Then candidate A gets 3, 1, 2, 3, 3, 1, 3, 1, and sum is 17. But B gets 18 points, and winner is B. So with this selection process, B is selected. But in the another selection process, they select A. These kind of things often happen in a voting system. Then which is a better way to select president? But this is a very difficult question. But as you see, this is a very interesting problem. Mathematically speaking, the mathematical background of the voting system is not too difficult, mathematically. I think now is a good time to share my method and experience of researching mathematics alongside students with people around the world. I can contribute to society by cultivating students' creativity. If you are interested in high school mathematics research, please contact me. By cultivating creativity is a very important step for the solution of many problems in this world. Thank you for listening. Thank you for listening.
Thank you very much, Professor Dr. Roy Mayadira.
Thank you.
Yeah, our dear participants, it is very clear on how Professor Mayadira presented to us on how to teach creativity in our different classrooms. And as you could see, it is very important to choose the right problem in promoting creativity in our science and mathematics classroom. So I am sure you have questions to ask to Professor Mayadira. Professor Mayadira, there's a comment here that the students who helped Dr. Mayadira were superb. Such young boys could conduct activities using Wolfram. Okay. I guess they are still thinking about the question, Professor Mayadira. But may I ask one question? I can see on the different problems that you have presented that it is really very important to choose the right problem. I am interested on the cup problem. may I know on what way that the students made variation on the cup problem?
But CAP program, it is quite easy for students to make something. So I think that CAP program is a good topic for maybe almost any class. But discussing is some they are quite ingenious in making many kinds of cups. So sometimes very difficult to measure the volume. So I think that if you have some kind of maybe three-dimensional scanner or something like that, maybe you can enjoy quite a lot of creativity of students. Yeah.
Thank you, Professor Mayadira. So I guess I need more time to, and maybe email to Dr. Mayadira on how to teach creativity on our classroom. And I would ask more on that cup problem using email. So I know that some of the teachers here and educators are really very interested and they are eagerly waiting for the workshop with you, Dr. Mandira, so that we would know more on how to teach creativity in our classroom. There's a question here on the chat box. Is there any difference between boys and girls in mathematical creativity?
Maybe I don't find any difference between boys and girls. But I think these days, girls are becoming more and more active than boys.
Oh, so the boys are more active than girls. Yeah.
Yeah, girls are more active these days.
So in that way, may I add another question with that? In that way, Professor Mayadira, since we found out that boys are more active than girls.
No.
So,
I mean, girls are more active.
okay.
And girls are more active these days.
Yeah, so I'm very sure that in our classroom, there are students who really need more help on how to cultivate creativity. In what way do you support those students in your class that need more help on how to cultivate? Because I believe that every person is creative, but there are some person who need more help on how to express their creativity. In what way do you help those type of students?
But this is in the usual math class, the role of teacher and students are very different. So teachers are teaching and students are learning. But when I do math research or that kind of class, maybe the status of teacher and status of students are very similar. So even if I'm quite old, I'm 65 years old, but we became a kind of friends. And people who visit our activity think that sometimes students are talking to me like a friend. But we need that kind of atmosphere to creativity, I think. So students become very relaxed. So don't hesitate to express their opinion. Sometimes their opinions are not so good, but they can feel free to express almost any opinion. I think that kind of relation between teachers and students are very important when we do some creative things.
Thank you, Mia. Thank you, Professor Dr. Medira, for that answer. I'm not so sure if I am the only one who have difficulty with the audio. But there's another question here, Professor Dr. Medira. Each student in classroom has different mindset. How do we upgrade their mindset?
Mindset? What do you mean, mindset?
Because we could see that students have different mindset. How do we upgrade or help students to change their mindset that they are creative?
Sometimes, usually we do research as a group. So sometimes some students are very good at mathematics, and some students are not good at mathematics, but they can propose some new ideas. So they can combine their strong point and covering weak point. So, for example, today one of my students, Miss Honjo, is going to speak maybe at 4 o'clock, 3 o'clock p.m. But I'm afraid she's not good at mathematics. But her role is to propose the idea. But usually she finds it very difficult to solve the problem she proposed. So I think that if you do as a group, maybe every member can contribute some way and cultivate creativity in as a group, I think.
Thank you for that, Professor Dr. Mayadira. I guess there are a lot of questions here. Professor Mayadira welcomes you to send an email so that you could ask more questions and then guidance on how to teach creativity in the classroom. Thank you very much, Professor Dr. Mayadira, for this very you really give challenge to us that it is very important now to teach creativity in our classroom. Thank you very much, Dr. Roy Miyadira.
Thank you.
Okay, thank you, Dr. Amelia Tibuan, for moderating this session. I agree, creativity leads to new ideas and knowledge. Okay, and to all participants and presenters, do stay tuned for more interesting research topics in the next session. Our next keynote address will be presented by Professor Dr. R.C. Singh on future of STEM education in India. Before we proceed, we are going to take photos. ICT team? All right. So, hope everyone open on your video. Okay, I will count. 3, 2, 1. Smile. How many? 3. Okay, we have 3 shots. Okay, the second shot. 3, 2, 1. Okay, and the third shot. 3, 2, 1. Huh? Okay, that's another shot. Okay, thank you, and see you again to everybody. All right, thank you.
All right, ladies and gentlemen, thank you very much, Dr. Wan Nur Azmin. Salamat po, Prof. Amelia, and arigato gozaimasu, Ryo-hei-san. Thank you very much.